Welcome to Spring LIB.
This is the answer to Chapter 11, problem number 53 from the Smith Organic Chemistry textbook. In this problem, it says, from what you have learned about enols and the hydration of alkynes, predict what product is formed by the acid-catalyzed hydration of this molecule that it spells out there, and draw a stepwise mechanism that illustrates how it is formed. Okay, and so the methyl ester is the product that's formed, and I'll draw that at the end. And so let's jump right into the stepwise mechanism. And so this is an acid catalyzed hydration. And so the first step is going to involve the acid. So the alkyne, the electrons of one of the bonds of the triple bond will pick up a proton from the acid and become protonated, and that will get us to this product. Okay. So we have formed a carbocation here at this carbon. And so since this is a hydration, the next thing that's going to happen is the actual hydration, the addition of water. And so water will come and the one of the lone pairs in the oxygen will act as a nucleophile and attack this carbon. And so we get the addition of water to that carbocation. And so that gets us to this product, or I suppose I should say this intermediate. So there's our water that's added. It has 3 bonds and only 1 lone pair, and so it's going to have a positive charge on it now. And another molecule of water can come along. Can come along and grab one of these protons. And so now that's been deprotonated. And so it's just going to be the alcohol. Okay. So 2 lone pairs on it now. And so what can happen here is that one of these lone pairs. Oh, no, you know what? I apologize. So before one of those lone pairs can attack, we are going to have to protonate that double bond. And so we made a molecule of acid in the previous step. And so we can just use that molecule of acid to accomplish this. So H3O plus, the prototypical acid. So lone pair, positive charge. The electrons of this double bond can grab one of these protons. Those electrons will revert to that oxygen. Okay, and so now we've protonated this double bond, and so we will have this. Okay, and so there's a carbocation on this carbon now, and there's two lone pairs on this alcohol oxygen, and one of those lone pairs can add in here, and when that happens, we will get this product. So now we are starting to resemble the methyl ester here. And in fact, the only thing that has to happen is a deprotonation. And so this oxygen is only going to have one lone pair. It's going to have a positive charge on it. But we have water floating around. Obviously, we've used water several times so far in this reaction. So we have water with its two lone pairs can grab that proton. Those electrons can revert to that oxygen, and that is going to form our carbonyl. And so we'll get to our final product here, which, as I said, is the methyl ester. For the sake of completeness, we should put all of our lone pairs in. So there they are. And I suppose I omitted them on this other oxygen throughout the entire mechanism. So let me go back and correct that. Okay. Yeah, and so this is the stepwise mechanism for this reaction. It's going to proceed just like an acid catalyzed hydration. However, the presence of that other oxygen is going to mean that instead of forming a ketone as we otherwise would, we're going to form the methyl ester here. And so that's what we do. That's the product, and this is the stepwise mechanism for it. And that's the answer to chapter 11.